a simple IoT device, you have very limited resources. You need to be very efficient with your algorithms, with your calculations, that one thing. But if we multiply it by thousands and they are producing data, let's say millions of megabytes of or gigabytes of data in a very short period of time, then you need to be very efficient with your infrastructure.
Each IoT device is going to send data at some fixed interval. Some cases, maybe 10 seconds, 5 seconds.
I believe when you do on-prem or you're managing your own data center, it requires more resources, more time. You are managing it, all the things yourself, but it adds the level of security.
It's not about the hardware only. You have to procure the hardware. You have to do, let's say at the start, I'm doing an MVP. I will only expecting some 10 to 50 users, like a few from the operations teams, a few from the admin side, few from the senior stakeholders, just to give them demos. Let's say 10 to 15 users. But if I'm going for an on-prem deployment end-to-end, I will have to procure them in.
What parameters should I look for when I am selecting an infrastructure provider, a cloud provider, in terms of security?
If you are managing security end-to-end, this means you have a complex project, your budget is high, you have an in-house security team who is doing the application testing, who is doing the penetration testing. Some complex project, you have the luxury of time, you have the budget, then you can go for this.
I've known you for like 5 years, and when we met, you were working as an IoT engineer at Hypernym, right? Yes, you were working there, and we worked for like 4 years together. And there, I have seen your growth from embedded engineer or IoT engineer to director of IoT infrastructure at the same company. I've seen your work ethics. I've seen what good qualities you have as an engineer. But what I want to know, and I would like my audience to know, how was this journey and why IoT?
First of all, thanks for the kind words. It's not about the IoT. I never knew when I was studying in the bachelor's that there is something called IoT. There was one good thing with me. Maybe good thing. I always love to repair hardware, your headphones, laptops, even mobile phones. So I was the guy in the friend circle or in the community who knows how to repair the hardware. So that thing was innate in me, repairing all the electronic devices. Even as far as I remember, even in the childhood, I used to open the toys.
So you could repair mobile phones?
Yep, I have.
I didn't know that.
Yeah, I used to do even laptops as well. Kind of a jugaad, but I used to do it. It was maybe it came from my father. He I have seen him do all the stuff in the household, from paint, from construction. So maybe that was in my genes to and the hardware or maybe the electronics. I like that part. So that was in me, the hardware part. Then maybe around 6th or 7th semester, I found about the FIP lab in our university. Me and my friends used to spend time there. Then we find about Arduino. There is something called Arduino that you can program to control lights and so on. So that was my first intro to the embedded systems, or you can say to control the mix of hardware plus software. So that was the first thing. Then I have done my final year project on the robotic arm that I was controlling with a gesture. Sounds fancy, but simply just coding some hardware to control motors and so on. So then I got some hands-on experience there. After that, I was not able to secure a job in IoT for I think 1 or 2 years. I was at that time I was shuffling between home tuition, an internship in the renewable sector, and a job in a telecom. So I was doing 3 things at a time. Then back in 2017, I started my master's in computer engineering, just to cope up with, because again, the hardware was the thing I liked the most. So then I started my master's from the Unity. Then I got the opportunity to start working as an embedded systems engineer. So at the initial phase, it was just about coding some microcontrollers, fetch the data from those sensors and send it to the cloud. Then it took me some time to understand that it's not about the firmware, or it's not about the C++ development. It's about the end-to-end development of the product. Then I found that the data, or the data from these sensors, these fuel sensors, these accelerogyro, basically motion sensors, it is helping us to track the vehicles. And then there is a mobile application, and there is a web application developed on top of that. So then it was my first exposure to the IoT. It was a UAE-based client. Then I got the opportunity to go there, visit the site. For the family, they thought I was going to Dubai, very fancy site, but on the contrary side, I was working with the mechanics. It was Ramadan, so almost 1 month I spent on the site during fast. I was working with their team, and you know about the
temperature and the sand and everything. Yeah,
but it gave me an exposure how IoT devices are running in the field. So that was my first exposure. Then thing evolved. I was lucky to work in such an environment. There are multiple projects, multiple kind of scenarios. Some clients have issues developing smart home appliances. It was a customer from Egyptian region. So I was lucky to work with them. Then at that time, my designation was embedded systems engineer. At that time, I got the opportunity to the team was leaving. The core development team was working on that project was leaving. Then I got the opportunity to work on the software plus hardware part of the things. So that was my first kind of exposure as a product owner.
And that happened prior to when we met, right?
Yeah, that happened. Okay. That was around 2020. So that at that time, I was 2019 and 2020, I was working with this client. So I was with the face of the company. I was meeting with the customer. At that time, it was virtual meetings. So I was gathering all the requirements, how to conduct a field test, because that customer was kind of a giant for the manufacturing space in the Egypt. I got to understand the other complexities of the IoT products. So that was the first thing. It gave me an exposure to the end-to-end software development, mobile development, infrastructure. That was my first exposure to the infrastructure side of things, because I had to manage everything. So, and unintentionally or unintentionally, I had to do it. Then when that development was done, I was writing the release notes. No one was asking me to do it, but just to make a good impression, because we have some stakeholders involved, to which we wanted to present that we are a very mature company, and we were evolving at that time. So it was just
kind of a startup at that time.
At that time. Then we were evolving. Myself also was evolving. What are the industry best practices? So that was that thing. Then this project got matured. I was working with the Microsoft team as well. It gave me a different kind of exposure, and that how infrastructure is being laid out. Then in 2020, I got the chance to travel to Egypt to run some field test, sitting with the client, and to run some Azure migrations there. So that was my kind of a first exposure.
Yeah. So by this time, you're not only handling or working with IoT devices, you are working or managing cloud infrastructure.
No, not at that time.
Not at that time. Okay.
It was 2020. My designation at that time was 2000. It's start of 2020. Designation was still embedded systems engineer. By January, I was promoted to the IoT lead. But still, luckily, I was sitting with the team. The other departments, and learning from them how they are managing their stuff, back-end team, front-end team, infra team. So I was understanding how
things work,
how things are working. So it gave me an exposure. When things move along, there was one thing that no one in the circle, in the development team, or no one was willing to do. That was the pricing of the infrastructure, because it was a kind of a complex thing. One miner was taking from 500,000 to With one mistake, you can ruin the whole budget or the entire product. So that was the thing. It was like awesome to me that I had to do it. So that was my.
And that's a very, as you said, it's a tricky thing, and you need experience and exposure.
At that time, I didn't have any exposure, but again, the opportunity was presenting itself.
And if you are only doing, let's say, if you are only doing part of the whole implementation, there is this application or a platform where IoT devices are involved, but they end up, or everything end up showing in front of the user on their mobile or on the web. There is very complex system involved in that, right? So if you are only, sitting at a place where you are working with a part of that, and you are asked, or you had to do the costing of the whole system. So what I'm trying to understand is that if you don't know how things work, for example, you don't know how the deployment would work, or what kind of VM you would need to deploy your system, or what kind of architecture you would be needing, what cloud services you will be getting. At that point, how a person who is just, working with hardware or IoT devices can do costing of the whole system.
Okay. At that time, I was involved in I understood how the other teams are working. Good thing at that time, the architecture used to be monolithic. Microservices were just coming up. It was 2020. So that complexities was not there. You just have to spin up a VM, deploy your self-managed database there, and you were just developing your application. So the deployment, CI/CD was not there, automations were not there, just bash scripting was there just to relieve your stuff. But the complex scenarios, the scalability, that part wasn't there yet. So things were simpler. We with the exposure, sitting with the Microsoft team, I knew how things were working. Then had to move out of my comfort zone, understand few other things. Then I was able to do that, figure out how these things are done. That was the first exposure to the infrastructure side of things. On the other side,
to go back to that place where I asked you this question, how could you do the costing? I wanted to ask you this question because I wanted to everybody know that what you are capable of doing, right?
Okay.
And that's one thing that I have observed, and I think a lot of young people and a lot of people who are coming into the industry, they ask this question: should I do that? Should I not do that? Is this in my JD? Is this my responsibility? A lot of questions before doing anything, right? And the thing that we like about, and I think we should inspire from this story, is that sometimes you have to do things which you have no idea how to do it. You do them, and that's the reason of growing from an embedded engineer to a director of IoT infrastructure at a company like Hypernym, or managing this whole platform.
So you mentioned that whether it's part of my GD or not, that terminology, I've seen people do it. Maybe at some time when I was a junior, I used to do it. But if you want to grow, then if you have bigger goals, then you have to keep this.
But they're not paying you for that. They are just paying you for being an engineer or do some coding. Why you are doing costing?
Okay.
So your motivation is to learn and grow.
No, see, there are two things. Okay, there are two things. One is the motivation, and one is that thing that maybe when you're junior, you don't know how to say no.
Yeah, you can't say no. Yeah.
Even if you want to do it, it's not my job, you can't say no.
Yeah.
So it's just a blessing in disguise. Again, what I have learned so far, I'm just in the journey. God has bigger plans. You look back, every single thing, every single deployment, every single site visit makes sense. The extra hours you have spent on things at that time you were thinking it's not part of your scope, not part of your JD. Maybe you are going with customer meetings. It was never a part of your JD. No one, when you are signing up, no one told that you will have to do this. But eventually...
but you signed a contract which listed your JD, right?
Again, if it's it's up to you. Okay, it's up to you. Like to you means like to the new people, to the juniors. What's your goal after 5 to 10 years? If you just want to be a software developer, principal software developer, because we have seen a trend, we have seen COVID. If you are, it's my personal opinion as well, if you are expert in one field only, then just COVID, one recession is going to take away your job. If you know multiple things, if you know how to take care of those things which you don't know about, you have that capability to learn new things, to adopt, then recessions will come, hard times will come, you will cope around one way or another. So that thing I believe in. For me, maybe I was not confident enough to say no. Maybe. Or then eventually, it gave me an opportunity to learn new things, which at that time, I was not like, I will be very honest, I used to curse that thing. Like, it's not a job, part of my JD. To my team lead, I will used to
why I'm
like, it's not part of my JD.
Yeah.
Eventually, like when I started my career, I was dealing with IoT devices. Basically, what are the IoT devices? It's just a very low resource hardware device with 8 KB of memory and up to 256 kilobytes of space. Okay. And you have to efficiently write your code in C++. You have to do multiple things. Like you have to get the data from the connected sensors. You have to send it to cloud. You have to maintain a bidirectional communication with the cloud. So that thing you have to do. Like eventually that thing I was doing. I knew how to manage the hardware quite efficiently. So then, like when I was doing the costing part, again, the hardware devices from some microcontroller shifted to a virtual machines. That is basically a Linux machine in the cloud. Again, a hardware from hardware inside a vehicle, like a vehicle. It's shipped from to the cloud. So eventually I was doing the same thing, managing the resources effectively, and then planning. When we are developing our IoT devices, we have to do a complete bill of materials, like which kind of sensors will be used, which kind of microcontrollers will be used, what is the price of each component, each price of each resistor, transistor. So then you have to take care of these things. That thing I was already doing. Like I was sitting with the PCB designer, so I knew how an end-to-end hardware or IoT device is being formed. So that thing was in me. But applying the same thing, those concepts onto a cloud-based environment, I had to go through a learning curve. Then I was able to understand how I have to understand what is a virtual machine, what is a Kubernetes cluster, how databases are working. Then you have to make a decision. Do you need to go for a self-managed database, or do you get a cloud-managed database? There are a few terminologies, platform as a service, infrastructure as a service. So then you have to decide what you want to do. Just for the listeners, infrastructure as a service means that you are getting infrastructure from the cloud vendor, and you are the whole owner of that. You will like, it's just a raw Linux machine. Whatever you install, whatever you do, it's up to you. Then it's platform as a service, so, like we call it PaaS. Then it's just like a managed database. Combo Atlas is the one which we usually see the developers are doing with. Firebase can be the one. Firebase will fall under the SaaS. Basically, Firebase will fall into the PaaS. Then you have end-to-end products, just like Google Maps, maybe, or paid subscription. These are software as a service. So there are 3 layers. One is infrastructure as a service, then platform as a service, and then software as a service. So these 3 layers. When then I understood all these concepts, and then there was one more learning. Then you have like, from the solution architecture point of view, then I have to adopt those things as well from the IoT. And at that time, we were also scaling up as well. Initially, there were very few devices, ranging from 100 to 150 devices. We were not receiving that much of transactions, so things were easy. But as we progressed along, we were receiving some new customers. These were MNCs. They obviously have a lot of data being produced. So What I mean from data we produce is that each IoT device is going to send data to the cloud.
A simple IoT device, you have very limited resources. You need to be very efficient with your algorithms, with your calculations, that one thing. But if we multiply it by thousands and they are producing data, let's say millions of megabytes of or gigabytes of data in a very short period of time, then you need to be very efficient with your infrastructure to handle that data, because for the end customer, you cannot say, okay, your vehicle moved, but we are showing that data to you after 1 hour or even after 1 day, which I saw happen during our testing. But yeah, of course, not in the production, we fixed that. But what I need to understand with that scale of an infrastructure and application, what it takes in terms of implementation, in terms of what kind of complexity you guys faced there. And the other thing that you mentioned about the team, that I'll come to later, but I first want you to talk about this.
If we talk about the IoT devices, let's start from the very end. IoT devices, each IoT device is going to send data at some fixed interval. In some cases, maybe 10 seconds, 5 seconds. So eventually,
it shouldn't send if the vehicle is not moving.
That is dynamic. Yeah, and that I was saying that it's a dynamic, like it's a dynamic in nature. Again, that things. Initially, when I was doing the embedded development back in 2018, 17, I didn't knew this thing that your frequency of each IoT device can be dynamic. So that was a person, like you have to, like again, if you talk about the IoT device, any use case, smart bulbs, smart sockets, temperature sensors, then you have to find a balance between regular intervals and then some event-based scenarios. For example, if the temperature has, there is a like change of, let's say 1 degree, 2 degree, whatever is your like threshold, then you are going to send the packet.
As you are not like be smart about when you are going to consume the resources.
So that evolution I have seen because the trends have been changed. Now we are seeing low-powered IoT devices. Initially, when we started, we were giving a backup of like 2 to 3 days. But now, like we are working with the sensors, easy 3 to 5 years and up to 10 years of battery life. And they are sending data like over the BLE, that is a Bluetooth efficient, like low-powered Bluetooth. So then you have to be very smart with the frequency of your IoT device with respect to the use case. And so that is one thing. Now coming back to your question regarding the scalability of infrastructure to handle that kind of load. So if let's say if you have 1,000 devices sending data around 10 seconds per day, but I was seeing maybe yesterday I was seeing the stats of one of the customer. Daily 1.8 million messages per day. That gives me
1.8 million per day from a single device.
No, multiple. Like
from multiple
devices. Like that for that particular use case, it is coming. Not from like why one device will send 1.8 million messages.
But so how many number of devices are there?
It was around 1,600 devices.
Okay, 1,600 devices. Each device is sending some data, but in total it's 1.8 million per day.
1.8 million messages per day.
And that message, to clarify here, is that one message. What is the size of that message?
It's around like 500 bytes.
Yeah, 500 bytes. So 1.8 million messages, each of 500 bytes. Yep. Okay, I think we can do the calculation, but in terms of if you can tell in terms of gigabytes or terabytes, how much is there?
I've seen like around that thing, transactions per second. I'm not recalling it correctly, but I was testing around 50 transactions per second. I've seen this thing. So 50 transactions per second. It like when all the devices are being moving, all the users are being accessed in the system. So that was the initial stats. Now the things the product has matured, it has been deployed into the multiple regions, so the transactions per second have been increased. I may not recall the exact transaction per second, but from the infrastructure point of view, there are a few things. One is the scalability of your infrastructure, and second thing is there should be no single point of failure. Okay. So single point of failure means, for example, if you have virtual machine that is receiving the data of all your IoT devices, there must be a mechanism in which if the CPU consumption, memory consumption is increasing beyond 70%, it should automatically scale up. So there are two kind of scaling. One is the horizontal scaling. Horizontal scaling mean that I'm expanding this cup. Okay, this thing I'm basically it is vertical scaling up. Same thing, I'm just scaling from 8 GB of RAM to, let's say, 16 GB of RAM, then 64 GB of RAM.
That we do with our personal laptop.
Exactly. When your laptop, you feel that it is getting overloaded, so then you simply you do a vertical scale up. Okay.
Yeah. Okay.
Then there is another kind of a scalability that you called as horizontal scaling. Okay. You have one cup here, one virtual machine here. You just have one other replica of this. Then you have another replica of this. Let's say if you have 1,000 customer, there is one VM. There shouldn't be one VM. Let's say 2 VMs, because there shouldn't be one single point of failure. If this VM is going down,
is it the same thing as load balancing?
Same thing, yeah. That thing I'm coming to.
I don't know.
At that time, when that load balancing thing, I was coming to this term later on. There should be a mechanism to avoid single point of failure, and then there are your load balancers. They will help you to distribute your load. Again, now things are changing. Distributed computing, again, the systems which we are seeing, even the TikTok, even the YouTube, these are distributed computings. These are the distributed systems which we are seeing.
So I'm trying to understand this load balancing or the horizontal scaling thing. So you have a virtual machine, or to make it simple, you have a computer, you have a server, and it's one instance with some CPU capabilities, with some RAM, and you are running your operations on it. Now, if you want to scale, one way is to add the additional resources in the same machine. Like I can increase the RAM, I can increase the disk space. That's one thing. But the other way is to add another machine, right? Which is kind of a horizontal scaling, or
we have to understand there will be different applications. Okay, if we say we are going for a vertical scale up, if we are upscaling the same server, okay, or same laptop, just like in your laptop, you have given a good example. There is always going to be a additional cost, and it's always going to be there. From 16 GB of RAM to 64 GB of RAM, you have to spend that amount. If we talk about the horizontal scale up, then that's the beauty of scalability, the beauty of the load balancers. You can set auto rules. If I'm getting 100 transactions, or let's say 100,000 transactions per second, you benchmark your system, and then you set up those auto scaling rules that for this much load, if the CPU consumption is beyond 70%, add up one more node. If again beyond 70%, then...
So when I am adding one more node, do you mean that I am adding the processing capabilities with another instance of hardware? So I am going to pay more for that hardware.
Okay. See, what happens is...
So what if I try to make it simple, what I'm asking is, what you said, the vertical scaling, you are adding one more RAM to your computer to vertical scale it. But what you have said is that in case of horizontal scaling, this is one computer, one processor, you have added another one. So you have two nodes or two processors running your system. It's balanced across, two systems. But still, in terms of costing, I have paid some money to add this another machine. Why not add more RAM or more CPU to this machine?
See, now there is a different perspective of the costing. Okay, you have highlighted a good point, but we have to understand one thing, that the infrastructure we are talking about is a cloud-based infrastructure. Then that's the main benefit of going from on-prem to cloud. You are only paying for what you are using. Okay. If I am scaling infrastructure vertically, if I'm adding more RAM on one server, it's always going to be there. If I have to add multiple nodes, I'm only going to pay for that 1 hour, 2 hours, 3 hours.
Yeah.
So eventually, if I look at the billing at the end of the month, I'm just paying a very minute amount, few dollars. And the pricing of this virtual machine or this servers, it's very low, $0.6, $0.5 per hour. So if you have like 30 hours, like if you have 30 hours of search per month, eventually
So this is, if I get this right, I'm using my machine here and it starts hanging because I'm putting too much load on it. I can have another machine here which can, somehow smartly start taking the load as well. But let's say my workload is getting down, so this machine I can put it aside or give it back to whoever I borrowed it, and again start using this. So I will only pay for this machine the time I need it for.
Exactly.
Okay.
That's the beauty of it. And if we now talk about some production environments, because as of now we were just discussing some scenarios. In the production environment, you set a base limit. Okay, for like one kind of application, you will need at least 3 or 5 instances of the virtual, of that server, of that virtual machine. Okay, that is your baseline. If there is more load beyond that you have to pay, and the bare minimum, let's say 3 servers, you can reserve for 1 year and 3 years. If you reserve for 3 years, you get a 62% discount. So eventually you have.
So that's how the cloud server providers are.
Exactly. Yeah. So basically, the baseline they are going to reserve, and the delta on top of that, you can do an auto scaling rules. So with respect to the search,
which is better, Microsoft or Amazon?
Depends what you.
Hypernym is using Microsoft, right? And they are partnered with Microsoft. So what's your answer? Amazon or Microsoft?
Okay, see, it depends upon your target industry. It depends upon your relations with the cloud vendor, because Microsoft has very good acceleration programs with the partners. But I've seen the trend with Microsoft. They have their whole lot of partners who are developing use cases on top of the applications they are building. So at that stage, and they are doing a lot of things. Like if I talk about why Azure is better or why Microsoft is better, in terms of IoT, there is one thing, data collection. That is one part. Then there is another part, controlling some IoT devices, turning off the bulb, switching off the light, controlling your smart appliances. That is second thing. The third thing is analytics on top of that. Here, Azure has been doing this for quite some time. Data lakes, Power BI. So these terminologies which we have seen. And now, this happened recently, the investment on OpenAI, huge investment from Microsoft side. And now they are giving Azure AI Studio custom copilots right off, like as simple as few clicks. You just integrate your database with the with the AI service, and you can do analytics on top of that. So, and from that regard, I will definitely prefer Microsoft. But there are some few regions which we are seeing where AWS is much more being utilized.
So the things that you have mentioned, aren't Amazon doing the same things?
Okay, regarding OpenAI, AI Studio, that I haven't seen, because that was the main reason they have invested so heavily on the OpenAI. That was because now you can't your application or your products can't have AI outs not included in them. So that is good. And analytics, Power BI, data lakes, we have been seeing for quite some time with the Microsoft. And then they have good avenues where they are promoting their partners. So that is why I think from my side, Azure is always preferred.
I'm gonna go back to this thing that you mentioned a while ago, distributed computing. We were talking about the scaling thing, and one way is to, if I am region specific, I am doing load balancing and doing horizontal scaling and all that, but I want to understand is how distributed computing or distributed cloud computing is working, and how in terms of all of these data collection points, like we mentioned in terms of IoT, 1.8 million data, we are gathering it per day. And how, I want to know, how does it affect, like if you have multiple deployments across regions, like you are doing in US and in Africa, and so how that would work, how this distributed thing work in scaling systems?
Okay, so for that thing, there is like one basic requirement: your application should be stateless. For stateless, I mean if I'm opening it from Singapore or if I'm opening it from US, the compute part is separate. Data storage part is different. If compute like you can't have database, like if you have like this kind of states issue, then the data in Singapore and the data in US will be different. So then you have to write some mechanisms to synchronize your data. So that is the base requirement. Then regarding your now things have evolved. Now we have microservices. Now if you talk about like the Kubernetes setup, you can have your Kubernetes deployed in multiple zones. So it gives you the high availability. If one data center is going down, your applications are automatically shifted toward your microservices is automatically shifted towards the other one. So that thing is already there. And regarding the geo replication, which you talked about, it depends on the application. For example, if you have static websites, just your normal websites, then a term CDN is there, content delivery networks. So basically what they do is they store the content of your website in multiple regions. So if I'm opening it from UAE, I will get a cached version. If I am opening from US, I will also get a cached version. So the response time or the end-to-end latency will definitely get improved. So so basically there is going to be data synchronization time interval, but depend on application. If you make it stateless, if you keep your database separate from the compute part, as we already discussed, you can scale up. And if you are feeling some database issues, then again, the databases are supporting your applications. You can host multiple instances.
How challenging that can be, like geo replication of a database, because if I'm, let's say, storing something here, is there a mechanism, or you mentioned platform as a service, if Microsoft or whatever the cloud provider we are using, is there some kind of underlying mechanism which is handling this, all of this data synchronization across different regions? Because for someone who wants to understand, okay, now I have stored my data in two places. One is, let's say, US and the other is Africa. So if I'm saving this here and here as well, so it's a redundancy of the database or the data. The same thing is stored in two places, or somehow how it is managed?
Okay, if we go with the managed services, again, you are paying for the platform as a service, then the vendor or the cloud provider is going to take care of that. Obviously, you will have to enable that thing. And now you have 2 replicas running or 3 replicas running of the same database. So you will have to pay a cost of that. So that aspect is there.
But every complexity of writing or reading or whatever, that is managed by the cloud provider.
If you want to do it yourself, if you say like, I have data center in UAE, I have data center in US, then you will have, imagine like doing it yourself. You have to write some pipelines, some cron jobs that are going to write the data. But if you are opting for a managed service, then this keeps you out.
When should I go for managed service versus my own data centers that I manage myself?
Okay, for that, it's a subjective thing. It depends upon the customer, because there is a recent trend I'm seeing with the governments. Like, it's not a recent trend; it's always there. It makes sense that the governments and the military institutions, they are much more careful with the data. It makes sense due to the nature of the organizations. So for that, there are 2 modes. One is complete on-prem deployment, and the second is the hybrid environment. So basically what you do is, on-prem means like everything is on-prem. You are managing everything from like your virtual machines, Docker container, databases, backups of those databases. That is a crucial part, because things can go down. So there is another aspect of the infrastructure is to have that backup plans, like redundancies. So that is one thing. The second thing is now things you have to, if you have these kind of limitations, the vendors, like cloud vendors, they have been compliance with the like data protection requirements that I've seen mostly in the UAE, Qatar region. micros. That was the reason why they are investing so heavily in opening up data centers in multiple regions. So that is one of the reasons.
Yeah.
Because they have to comply with some requirements that at any given time the data will not leave their country, their region.
Yeah.
So the cloud vendors, they are assuring this thing. So they give you certifications on top of that we will ensure you so the data will not leave inside the defined premise. So that is totally cloud-based native security. There are a few other things as well. We will, let's come to the security part later on. But now what we can do is we can go with a hybrid environment. So basically databases will be hosted if we have such kind of scenario. Databases we can store on-prem. This
which means I have my own store of database and I'm controlling
you have control on every single thing. The compute part, that is a stateless thing, or if the data of the IoT device is encrypted, that you can do if you have that kind of a scenario. Before sending, you can do an AES encryption on top of the data, raw data, and then when you receive the data on cloud or on-prem, you do a decryption and you store the data there. So that thing is can be done, but again it depends upon the customer, because there is going to be a technical challenge on the IoT devices. You have to manage the infrastructure, like manage the code base of IoT devices quite effectively. That is one thing. And then if we talk about the general IoT security, you can keep the compute on cloud, the anonymous data, which like there is no relationships. The raw elementary is coming up with some bunch of numbers that this device is here, or the temperature of this device is this. Okay. So that is there. And after processing, or while you are processing, this data is being stored only into the on-prem database. So your relational data means the data, and on top of that you are writing your reports, that like that sensitive data or the user's data, profiling data, that stays on-prem. So that is the thing which I'm seeing in the market as well, the hybrid infrastructure. So this is the option which we can go for.
I believe when you do on-prem or you're managing your own data center, it requires more resources, more time. You are managing it, all the things yourself, but it adds the level of security.
Again, there is an investment there. If you talk about, there are few areas, like it's not about the hardware only. You have to procure the hardware. You have to do, let's say at the start, I'm doing an MVP. I will only expecting some 10 to 50 users, like a few from the operations teams, a few from the admin side, few from the senior stakeholders, just to give them demos. Let's say 10 to 15 users. But if I'm going for an on-prem deployment end-to-end, I will have to procure that infrastructure. So that procurement, hardware and procurement needs to be there. Then there is going to be the networking constraints. All of that infrastructure has to support that kind of like gigabits per second transfer rate. That's going to be there. Then you have to manage electricity, fan, like the cooling of that system. Then you have to manage the backups of that infrastructure as well. So again, it comes to a very complex infrastructure, which now the cloud vendors, they give you the flexibility, spin the VMs, offload it there, do your MVP, and simply if you have that kind of a requirement, then go for the hybrid model. Like then it's an option. The option is there.
So what does it take to build your own data center? You gave an example of 1.8 million packets or messages per day for a single customer. Let's say it's a social platform or what kind of platform, but those number of transactions are happening, let's say 1 million transactions per day. Then what kind of data center one would need, and how much it can take in terms of cost and time of implementing that data center or making that data center?
Okay, so for that, transactions or the number of users was one like parameter only. Then we have to look at the application performance, how much. For example, if you are opening Chrome on your laptop, definitely it is going to take from 2 GB to 3 GB of RAM. Even without, even just opening that application is going to take that kind of a RAM. Some VM, some software such as like Photoshop and so, they might take 5 GB of RAM.
Yeah.
So it depends upon the nature of application. So you have to benchmark your system. You have to know at if there is minimal load or average load, what are the specifications I'm looking for? It can be from 200 GB RAM to like 80 core CPU. That specification, like ideally you need this, and you have to figure out your peak loads as well. Again, that thing you have to sit with your business team, how you want to market this thing, what are your expectations for first year, second year, third year, these kind of scenarios, and then you are going to do the procurement. Like it's like, just to answer your question, transaction per second is not the one parameter. You have to take into account the other parameters as well, like the whole performance, the benchmarking, how much database requirements you will need. Because if your application is read intensive, then you will need some caches there as well. If your application is write intensive, then you need that kind of database that is going to support these kind of transactions. So you will have to go in depth, understand the whole architecture, how you are going to do it. Are there hardware load balancer or software load balancer like Nginx base, or you are actually deploying a physical load balancer there? So that thing, once that is done, after this whole analysis, you will come up with some numbers that for normal nominal load, you will need this kind of computing, and for your peak, you will need this kind. And then there is going to be an investment, and then you will go ahead with your on-prem infrastructure.
Okay. Setting up your own data center. That's what we were discussing, right? And you explained that it depends on your needs for whether to go for on-prem or for cloud. So what's more in... Actually, I wanted to know more about the costing and the easiness of setting up your own data center, or the difficulty behind setting up your own data center.
So we have mainly discussed about the pricing part. All of things we have already discussed. There is one more thing which the new undergrad students or the junior students or whoever is willing to invest some time on the raw deployments or setting up the infrastructure who can do. You can easily get a Raspberry Pi. It's basically a credit card size single base computer. Just your entire Linux server you can deploy in that. It's basically...
So this is doing the same thing, setting up a data center, but like at a very small scale.
Yeah, basically that one that piece of board is just like a Linux server. It comes with 4 core CPU and 8 GB of RAM. What you can do is you can couple them 3-4 of these Raspberry Pis, install there is a software called Rancher. You can use it to set up your Kubernetes cluster on-prem, and you can use it for database deployments, some Kubernetes microservices, some dummy projects, or maybe your the final year projects for the undergraduates. So it will give them the flavor of the infrastructure along with managing the end-to-end applications. So when these if I see a resume with some pictures or some references, how they have done, how they have managed the databases, definitely that fresh DevOps engineer knows a lot more. Then there is a whole most of the tools are open source. If we talk about Jenkins for the automation, so that can also be used for that particular thing for the deployment. Then you have your monitoring tools such as Grafana, so that can also be deployed again on same thing. It can be deployed on anything, but if we talk about someone who is willing to learn the on-prem or the raw hand-on infrastructure, and they don't have the access to the cloud account, they don't want to procure that. That is also economical. But if they want to get a hands-on on the raw infrastructure, that can be a very good idea to start it from there.
So they can use this to practice their skills as to someone to set up infrastructure.
Yep. So if imagine usually the undergraduate projects they come with a group of 3 to 4 people. So one who has interest in infrastructure or DevOps, he is managing this thing. He or she, he's they're managing this thing. The other team, they can focus on the application part. So and when you see this end-to-end project, and you can you can put some lights on this, some fans on this, and you can present this. So it will look like a very good thing. I can share some pictures with you later on. So just how other people have done this thing. So it will be both the mix of hardware, like the infrastructure, core infrastructure. You know how the complexities of setting up a database, managing all that thing, and writing an application on top of that. So that group they will get an edge over the other.
So you have the complete control over the infrastructure and the deployments.
They know how product, it's kind of a product for them. Maybe a facial recognition attendance system, maybe some other retail, like real estate based web application. So they own end-to-end infrastructure. So that thing they can do. Else they can simply go for the cloud part as well. But if they if someone is really willing to understand the core of infrastructure, this can be a good thing.
Yeah, that's good. And the other part, I think, when we were discussing about setting up your own data center, I was thinking about this part where if I go to some cloud provider, like if I go to Microsoft and Amazon or any other cloud provider, what I am doing is I am putting all of my data into their data centers.
Okay.
Right? Now, one part is where you mentioned that the data can stay in my country, but still, even if it stays in my country or it goes to some other country where the data center is located, still the data is getting stored on those data centers, and they are not my data centers. They are controlled by the cloud providers. Now, what I want to know first, from the provider's perspective, how secure is it, giving your access to your data to some third party who can do anything with your data?
Okay.
I know there can be encryptions and stuff like that. So when we use Facebook or WhatsApp or any other platform which is saving my data, I want to keep it private. They are giving me sureties like, okay, it is encrypted, we're not seeing your data, we're just saving this and stuff like that. But when I'm deploying my application, I have my customers and I'm saving their data onto someone else's cloud infrastructure. So I don't have any control over the security.
No, there are multiple layers to this. First thing is this, which I have seen the vendors do. Even if you talk about, the thing you will do is you will develop your application on top of that when you are deploying your services, when you are storing the data. So eventually you will have your application specific data. These vendors, they never go inside what's stored. Even if you open up a support ticket with their technical team, if you're facing some issue with the database creation or something like that.
What do you mean by never? They never go, like ethically they never go, or they can't go?
No, they can go, but they will not go. They will not go inside and, like, for example, if you're storing the data of your customers with the credit cards and so on, they will not go inside what you are storing inside the databases, what's inside the actual infrastructure. They will not go. If you are if you are opening a support ticket with their technical team, you acknowledge that this data will be shared. Then you intentionally give them the access to the data. They ask for this. Apart from that, they only have the access to the high level stats, such as how much consumption you have on your cloud tenant, how many resources you have. These kind of high level stats they will see. But what's inside a database, they will not. They have their legal team there, so that thing is already there. Then if we talk about the application security, then there are multiple layers to it. For example, if you talk about simple database, there is encryption at rest, encryption in transit. So you have to manage those things. Then if you talk about the end-to-end security of your infrastructure or your application, there are multiple services or multiple things you have to think about. The first of them is the DDoS attacks. DDoS attack is simply denial of service. For example, you have your application up and running. That can be a website. I start bombarding your application with anonymous traffic. And one given time, it will slow down. It will start behaving abruptly. And then I can find a weak spot weak area, and I can simply get your access to the your application. So for that, there are DDoS services by the vendors. These can be enabled to prevent this thing. They will mitigate those. So for example, if they are seeing a surge of traffic from a particular region or a particular IP, they will take care of it. Then the next layer is the web application firewall. So basically a WAF, or basically there is SSL termination is also there. So you set up policies there. For example, what kind of like SQL injections, or what kind of like there are some standards there. So you enable policies there, like these are the policies, these are the standards. There is a HIPAA compliance, GDPR compliance. They come up with their own a set of standards. You enable on the web application firewall. So whatever traffic is passing that, you will make sure that this has been taken care of. Then from the other side, SSL is now like quite basic. That is like most of the tech people know this. Everything should be SSL secured. If you talk about the IoT devices, then there is a then one thing is infrastructure security. Then there is another layer regarding the IoT devices security. There has been some incidents or some like requirements where we have to secure the IoT device as well. So one is the server side authentication, as the server side security with SSL. Then you have client side authentication as well. So it can be done with the hardware module, or like just like your TPM devices, or you can embed some client side certificates on the IoT device. So basically what it means, your server is the authenticated one, just like an SSL. It's sure like from a like authorized body that the server is legit. Then client as well, that this client is also legit. So when there is a communication between them, you can make it encrypted. So now you have a complete like cycle, like the ecosystem is secured. So that is a part as well. Then there are other securities as well. You can harden your like if you talk about the virtual machines, you can do port hardening. Port hardening means that you only open those ports which are essential to you. You know your application, it will have front end, back end, or some other WebSocket based thing. So you're only opening that. Then you can do whitelisting on top of these. That, for example, SSH or RDP is only allowed by one of the IP of the office. So no one has access to the direct access to your virtual machines. Then you can do secured SSH on. There are other tools, like you can do a VPN tunnel. Like you make sure, like from the application side of things, you have tools there. And when the developers are accessing this thing, the security is already there. Now there is another trend that you only give the bare minimum access to the resources, to the developers, to the DevOps team that is required to get the job done. You don't give them the direct contributor access, owner access to all the resources. And I've seen one customer doing this thing, no direct human access. What they wanted was they only have given the read-only access, and whatever you have to do, whatever infrastructure you have to create, it is going via pipeline. So here infrastructure as a code comes in. Whatever you have to create, you write scripts over Terraform or for that. So when you run that, you get like acknowledgement from the like whoever is your customer, the like the stakeholder. You get an approval on that, and then what you do is you just run those scripts, and your infrastructure is created. So no one has direct access to this, and everything gets created in a very secured environment. And so you are covering multiple aspects. One is the application security. You have some services there. Then you have the other thing is regarding this secured infrastructure creation, that no one intentionally can mess up your system. And then you have the other security as well. Then there are other services such as Defender for Cloud. There are some people get the logs of their systems. They integrate with their SIEMs. Basically, then they monitor all the system logs, how the users are behaving. So then security, you can do it at multiple levels. It's up to how much of investment you want to do at the security. But as of now, security is essential. If you are dealing with the data of the customers, security is always there. So that that is essential.
Yeah, I think security is a very sensitive topic not in IoT, but any kind of infrastructure, because you need to protect the data. You don't want any unwanted user to access your system or your client's data. And I think you have to comply with different policies in different regions, which is, I think, a good thing. Like in Europe, you have to do GDPR compliance, and I'm not sure about the Middle East region, maybe Accra or something. I'm not sure.
GDPR is also there.
Okay. Yeah, that's good. So, but what you have talked about is you have given us a list of to-dos that you need to ensure so that your system is secure. But what I want to go a bit deeper in this, because I think it's a very sensitive topic, and a lot of things, or in terms of data security, is happening around the world for large number of years over past few years, right? So you mentioned firewall, and this reminded me of this firewall incident in Pakistan, where someone was saying, maybe it was a minister, that the network got slowed because of people were using VPN, and there was a lot of debate about what are they doing with firewall and what's happening with our country's internet connections, why everything is slowed down. So I think that's just an incident, but if you can go a little deeper on what a firewall is, and when you are doing you are going to a cloud vendor, what you should be looking into their firewall support, or what they are providing you in that. And also, if you are doing on-prem, do you need to set it up from zero, or how do you set up on your on-prem data center?
So basically, as the word say, firewall, it is, I will try to summarize in simple words. Just a wall protecting your infrastructure from the outer world. So what you do is you have controlled, I'm forgetting at which layers. I think it was OSI 5, 4 and 6 layer. It does give you a protection, but basically you get an interface to control from where your application will be accessed. So that is one thing. Then you get the access to the content of your application. For example, if you are sending a post request, what is being passed in that post request, so that content you can analyze. You can set up rules on top of that, and then you can do some redirection on top of that as well. For example, SSH, normally it's port 20 to 20. Okay, normally when you do an SSH, it's port 20, but for some reason you have to give an access to the developer who is working remotely. You don't want to give them the direct access over the port 22. You do a netting there. Netting means network address translation. So this port 22, you map it to 465, some random port.
Yeah.
Okay? So now when he is doing an SSH, he will enter an custom port, like with 2 colons, 465. It will come to firewall, and then firewall knows 465 means 22, and then you can do rules there. Like if I'm getting, like, public port is this one, then then this means I can redirect is to the this IP of this which server, that the private IP of this. So just from the broadest aspect, your spokes, your servers, they are not directly exposed to the internet. Everything that is coming, it's coming at the firewall, and then at firewall you have multiple rules. Like if I'm getting traffic at port number 465, I have to go to the server 1. If I'm getting a traffic at 462, then I have to go to the server 2. So now you have a segregation. For example, your front-end developers or the customers from Pakistan, they are going to one server. Then the customers from another region, like if they are coming from there, they are going to another like region as well. Then you can do blocking as well. For example, you don't want to, like you simply want to, just like the example I've given, you want to revoke the access of SSH. So you can simply just click the SSH access is gone. Then you can do whitelisting on top of that as well. For example, the static IP of your developer, you can use that IP. If someone is requesting an SSH over from that IP only, then he is allowed for the SSH access. Else, no one then you give then that is an added security. Then again, that is just tip of the iceberg. Then there are other like you can go for like a whole network. Like IP tracing, like the network tracing there as well, the complexity. Then there, the cyber security departments come in. But from the general view, what firewall is being used, that is the tip of the iceberg, how it is being utilized. Then you can use it with other service as well. You can use WAF. That basically, firewall will give you the access to like protection at the port level, network level. Then you have an application like where you have like web URLs like /login, /logout. So if you want a protection on those URLs, then you will use an application gateway or web application firewall there. So your application level firewall is going to that will give you an additional added layer on top of that. Then you come toward your compute. It can be a Kubernetes cluster. It can be a virtual machine. It can be like mostly it's Linux, like a Kubernetes cluster or a virtual machine. Then the hardening of that particular server or that particular node will come jump in. For example, there are if you're using Nginx, then there are some best practices on a daily basis, which that is the reason they always push the new patches with the security updates. You should, and they tell you that this was the vulnerability found in the previous version, so you should upgrade. Then if you are going into the production environment, you should disable all the debugs, all the developer modes that you are using. So like that, like there is no like vulnerability from that point as well.
We were talking about firewall and the rules in it, and you provided a lot of you talked a lot about what's happening inside that. That was really good. But I'm trying to always, I'm doing this with any engineering team or engineering person who is coming here. In today's world, we are trying to make things really simple for the end user, whether they be using our platform as a service or SaaS, software as a service. So when I talk about providing someone an infrastructure that is secured, scalable, whatever they need in it, I think security is the basic requirement. Now, I can create an application in a no-code tool or a low-code tool. They are handling all the securities and all of these firewalls and everything, HTTPS. I don't have to worry about them. Now, when selecting those vendors, you say, I think at one scale, at one point, you are doing everything yourself. You are managing, you may be hiring people, or you are doing it yourself as an engineer, as an infrastructure expert. And on the other point of the scale, you are relying on someone else to do it for you. Where, for example, for a low-code solution or even PaaS, I'll ask someone to do all of these things, and I'm not touching anything, but I want my data to be secure. And they will give me some simple interfaces to apply some privacy rules. And even I think a platform as a service like Azure or Amazon, what you do is they give you a firewall and they give you very simple ways to set rules. Like you don't have to maybe in some cases write scripts, but if you want to dig down, you can go at that level as well. But if you are setting up your own infrastructure, in that case, you are doing all those scripting and going in details, everything. So we have 2 points of scale. One is where I have control over everything, but everything is complex. And at the other end, everything is done by a vendor or my infrastructure provider, and I'm relying on them to secure my data. Now, my question is, what parameters should I look for when I am selecting an infrastructure provider, a cloud provider, in terms of security? What are the key factors that will tell me, okay, I should buy infrastructure from this vendor and not from this?
Okay. Now, you have raised a good point regarding the security. Like, to summarize, whether to do it yourself or go for a pre-managed platform. Okay. So first thing is the complexity of the project. Because if you are managing the security end to end, this means you have a complex project, your budget is high, you have an in-house security team who is doing the application testing, who is doing the penetration testing, who is giving you a feedback. Because if I'm creating an infrastructure and no one is giving a feedback and I'm saying it's like perfect, it's like it's beyond amazing, it doesn't make sense. You have to do an security testing there. So if you have some complex project, you have the luxury of time, you have the budget, then you can go for this. But if you are talking about low code, no code, or some managed services, there are some vendors who are providing a WordPress based deployment. So when you go select these, they will give you an cheaper price, and then you can look at the specs of these. Are they providing you WAF? Are they providing with your DDoS? Are they providing with you the front doors security as well? So these are basically then you give you access to the firewall as well. Can you do some tweaking on top of that as well? So these vendors, they already have this thing available on their websites. In their basic tiers, they might not be giving this thing. But if you go for their premium tiers, their security will be increased. So it's entirely depends upon the nature. Because if you talk about, let's say, firewall in Azure, it's around $1,000 service per month. If you talk about DDoS, it's dedicated DDoS for network. It's around $3,000 service per month. So if you are just if you have a very small application where you are just managing your WordPress application, it doesn't make sense to go for your application is running on a one virtual machine and you are paying around 4,000 for the security. It doesn't make sense. That thing, in that scenario, you can simply go for any good tool. If you talk about the websites, Hostinger is there. There are some other vendors as well. You can do an analysis between them. You can set up calls between their sales team, technical team, understand them, understand how they're doing this thing. And definitely they are going, if you ask about the security, they will give you certifications. They will assure to give you the right material. So then you can pick and choose which one with respect to the cost is the best one for you. But if you have some complex application in which, again, if you have that complex application, it means you have those customers who are willing to pay these kind of revenue. So again, then you can opt for that. One good thing, if you talk about this complex application as well, let's say you are an organization, you are a ministry or something like that. You are managing your infrastructure on the cloud. You can share these security components. So for example, if you are opting for DDoS, it's not that for every single application, for your mobile application, there is some product for the mobile application, some product for the web app, some for marketing, some for retail stores. So for every single product, you have to bring in the security components again and again. Here, there is a hub spoke architecture. Hub means all of your traffic will come on the hub. So that is just central security layer. You can share these security resources. So when you look at the overall security utilization, security budget, it will get distributed in all the departments. So when you divide with that, you will get a very nominal amount. But that luxury, only the bigger clients, bigger these bigger customers, they have that luxury. If you are just starting up with your own small website, then the easy option is go with the vendors. Simply do a cost analysis there and simply pick the.
So if you are doing just a product launch where you want to test it out in the market, an MVP, then it's good to go with low budget and these kind of solutions who are providing you everything in security. But if you are, let's say, you are building a tool for in-house, or let's say someone is building some application which is going to be used by a large number of users, they have the budget and everything. In that case, they can spend more on it, and by that they will have more control over it. I think it's the rule between the customization and ready to go live thing. That's the difference. You will have less control, but you have speed. You have more control, but you don't have speed. You will have to maybe spend more resources, spend more time there to have this thing. Okay, so my question regarding the other part where we need to manage everything in-house, or where I am, because you are leading an infrastructure team. So when I am going to build an infrastructure or manage an infrastructure, what kind of a team we are looking for in terms of, do we need to have security guys, DevOps engineers? Can you tell us like how to build a team that can manage infrastructure similar to what you are doing at Hypernym?
What I'm doing at Hypernym, like again, there are multiple products there. So for a normal startup, things like small team, it might not be applicable, but I will give the let's start from the beginning. And with respect to the application criticality, team can be opted. So if you are simply starting up with some mobile application or a website based thing like that has a database, you are storing the data of some users, coming up with some basic reporting. Now there is a trend that after COVID, there is an expectations from the software developers as well. They know DevOps. They understand how can they deploy these things. So if you are just starting, you mentioned MVP or something like that. If you now the senior developers, who have a 4, 5, 6 year experience, there is an expectations they will take care of the deployments. Of course, the infrastructure part is infrastructure creation is one time only. If the infrastructure guy is good, he is going to set up all the auto scaling rules, which we have already discussed. Like with respect to the load, it will increase. He will do the price reservations for you, so you don't have to day in day out. There is a shift. Like the dev team, the developers, they can understand the deployment, and the infrastructure team, one senior guy can be enough for that one project. He can spin up the infrastructure. He can train the team how to utilize your automation tools. For example, if your developers are doing deployments on a daily basis, they are pushing their code on the GitHub. But again, it takes they are pushing their code on GitHub, then they are manually pulling it on the server, then they are manually deploying it. Each build is going to take around 5 to 10 minutes, and end-to-end each deployment will take them around 15 minutes. This entire thing can be easily be automated. You can set up the pipelines. One guy is enough to do this thing. Create the infrastructure, do the automation. Then the other part is the monitoring of your logs. He can set up some tools there as well. He can train the team. You can come up with some of your internal processes to train. That is one-time effort. If that leads are being trained, then knowledge will automatically pass on to the other team members, so they can understand this thing. And eventually what will happen is they will also, developers or the dev team, they will also understand, because now I'm seeing a trend in the curiosity inside the development team as well. They want to understand, they want how Azure is working. Maybe to put on the resume, it's a demand, it looks fancy or maybe something like that, but they are willing to invest some time. And that is again, it's DevOps where it started, development operation. It was not that it's infrastructure team, they are sitting alone. That team was already there. IT team, infrastructure team, it was already there long ago. Operation team was already there. The DevOps, it's the one who is in between, who knows the development constraint as well. He can be a developer. Okay, he can understand the Azure part. If he is willing to do this kind of automation, he can be. And the senior developer will know the basics of this thing to get this thing right.
Yeah, I think there is this. I saw this picture where someone in the dev team is throwing, when the thing is done, they are throwing it over the wall, and then there are operation guys who will take care of its deployment and running and everything. But this changed when that wall was, melt down, and now it's DevOps. Right? Yep. So the developers are doing that thing as well.
Yep. So basically, then again, if we go towards the...
I will actually try to build on that example. Is you have developer, you have operations, and then you have infrastructure. Right? So infrastructure is separate from ops. Are they three separate things? And now in latest trends, they are merging, and one person or one role is doing all of that development, operations, and infrastructure.
Operations teams is responsible for day-to-day operations. Keeping, having a look at the logs. They will not understand automation that much because their job is just to, they have a predefined interfaces in front of them. They have been told with their documentation, if you see this alarm, it means there is a P1 criticality. If you see this alarm, then this means there is a P2 criticality. You have to call this one. And if you see this alarm P3, it means everything is down. Then you have to take those kind of steps. So this is the normal operations or L1 team or L2 team. They have hierarchies there. So they are managing day-to-day operations. It can be the operations of your your software platform, like creating users, onboarding them, or doing normal device installations and things like that as well. Then the development team, usually they are mostly inclined toward the new products. They are working on that. Then you have support departments or a merge of both, who knows how the DevOps. A person who is in the DevOps, he should know what's inside the code base. For example, if I'm being given a Java application, I don't know, because I have to write a Docker file for that. I will have to, that Docker file will include the packages for that Java. So I will have to sit with a developer to understand these things. I can't be just like an operations guy who doesn't know anything about what's inside the application. So I have to know this thing. Then there are few scenarios in which when the developer and the DevOps guy is sitting together, and they come up that these are the most critical areas. These are the kind of alarms, these kind of debugs that will come before an incident will happen. We talked about latency. There can be something, user errors, for example, some database warning or some database latency issue. So they can agree on, and they can set up alerts on top of that. So that can be the thing. So both of them, they are supporting each other. So that later on, when the operation team is seeing some alert, they can do this thing. And an ideal scenario, industry is trying to do this thing. Maybe some people have achieved already these things, just like some Netflix and all. They already have end-to-end automation. Even they are injecting faults intentionally. There is a tool such as Chaos Monkey. But it does is it intentionally create it will corrupt the database. It will bring down one of the service, and they will generate report on top of that. And once they create these faults intentionally, random faults, the system will self-heal. It will generate in the report that this kind of fault was created, and now the system has healed. Then again, these kind of things, these huge organizations such as Netflix are doing, but the trend is going toward there where things are getting simpler. It is not, again, with that the usage of ChatGPT, it's not that much complex to come up with some Jenkins pipeline or do some CI/CD there, and everything is there. You just have to adopt. Eventually, you have to find out which are the areas your team is most stuck in. If they are struggling to understand the logs, for example, some incident happens 8 days ago or 5 days ago, and the customer is reporting it now, and you don't have access to the logs, and they are going to the command line, typing grep, finding out the windows. It's complex for them. So the DevOps resource who must always be learning, testing new tools. He must have already the best tools in place. He can ask them, go use Grafana, go use Elasticsearch there. You will be able to fetch the logs. Then he will support in the debugging. And regarding the day-to-day operations, you mentioned the day-to-day operations. he can, the DevOps guy, he can easily automate the scaling up of the infrastructure. We talked about the scaling up of the infrastructure at the hardware level, at the server level, but the scaling up also come at the microservices level as well. For example, if you have, one thing we have discussed, there is a core hardware infrastructure underlying. We talked about the vertical scaling, we talked about the horizontal scaling. Then there is scalability at the core application level as well. If you are writing a microservice, you have a YAML file there. YAML file, you can simply say it's just a configuration file. You say like which, like how it will run, these kind of preset commands. Okay. Then there is a core part of the like scaling up. You can set up rules there. If the consumption of one pod mean that instance of the microservice is exceeding 60%, create one more microservice, one more instance, replicate that, and this will keep going on. So now imagine a scenario where you have only one microservice with, let's say, 100 users. Users keep on coming up. There is this rule which we have discussed, horizontal pod accelerators, HPA. It is going to upscale your pods at the inside the infrastructure, and when they're like, and each pod is having a let's say consumption. Each pod, each microservice, you can put up limits there as well. That this pod will have, it can only consume up to 5 MB of RAM, 500 MB of RAM or 5 GB of RAM. Then when you sum it all, you will have the complete infrastructure utilization of your one server. And if it is going beyond that, then we have already set up the like the scale up of that thing as well.
Yeah.
So this thing will become totally automatic. If the users are coming up, the microservices will scale up, and if the infrastructure is not capable enough to handle these microservices, the infrastructure will scale up. And let's say you have some fault, some microservices are not working properly, then you have with the if you go to the Kubernetes documentation, then you have liveness probe there as well. The service can check itself if I'm alive or not, if I'm alive or not. If it is not alive, it will self-destruct. So you don't have to worry that one of my pod is not working. So that thing is also taken care of. Now things are evolving. And then let's say one of your server, someone has gone there, maybe it was due to some upgrade, it has gone faulty. Okay. Then you can set up rules on top of your entire application. That entire application, let's say it has onekode.com/login. If my login is working or not. Then there is another tool who is just checking, keeping an eye on the system. If he finds out that this whole infrastructure is not working fine, replicate the infrastructure, deploy your latest code there, change up the firewall redirections rule. So now the traffic will come here. So again, now you have eliminated the manual efforts where the operation team was going to generate a ticket where someone is going to again, there is going to be a back and forth who has to take care of this. So entire thing can be automated. And you talked about, so you asked about how many people you need. So again, a good DevOps engineer, 1 or 2, depends upon how much active projects you have. You can that will give you the answer. Then now things are the cloud vendors are making things easier for the security side as well. So you don't have to hire those security people to do the integration. They will give you overall cloud for security posture. So you have 68%, you are 72%, and they will give you recommendation as well that you have not enabled encryption at rest. You have not upgraded the OS of this virtual machine. So they will give you recommendation.
Okay. So we've discussed about infrastructure, building a team which can handle the infrastructure or DevOps. You mentioned, I think what I get from your answer in terms of building teams, you need less human involvement if you go for automation and tools, right? If you have more automation and tools, then you need less human effort to manage it all. So to manage an infrastructure like where I am handling, let's say 1 million data packets per day, one DevOps engineer would be enough. If there are tools to manage the,
what we have discussed is that one DevOps engineer for a small organization that are working on 1 or 2 products. So but he should have the background in which he is able to automate. He must have hands on all these technologies. If he has that hands on, then he will help you to lay the foundation to eliminate the human intervention. So that was the thing which we have discussed. But if you talk about the team, you should, like, depending upon the nature of the projects, multiple assignments you are working on, 5-6 person in the DevOps team, because there is one essential thing. You need to dedicate 1 or 2 resources who are constantly learning new things, because you don't want to be stagnant. You don't want to be stuck with the old technologies. So that thing, that is the core thing. For example, now technologies or new tools are coming on a daily basis. So you need to keep on testing these things. For example, if you are only using one tools for your automation, Jenkins, let's say Jenkins, at times will come, you will realize the limitations for that. So then you will have to keep on adding Argo CD on top of that. Then there will come a requirement. You will try to eliminate the manual testing. You have to integrate that Jenkins with the Selenium code base as well. Then you will try to have the vulnerability scanning of your code. Then the SonarQube will also come. So these things will keep on evolving. So you need to dedicate few people in the teams that are always in mode for learning new things. Then there is a part of certification as well. The technologies, for example, even the UI of these tools from the cloud vendors, it keep on changing. So you have to new things are coming up. So you have to constantly at least be in touch with the new technologies, with the new Kubernetes versions. What are the new things that are coming up with the new Kubernetes version? So that culture you have to do. You have to take care of, and ideally keeping, if you have the budget, one security resource or someone who is inclined toward the DevSecOps. Basically, sec is the security part, so that you can integrate. It can be a static code analysis using SonarQube. It can be some testing of your overall infrastructure security. You can run some pipelines there to do the evaluation. So based upon that, based upon your product, you can decide the number of teams. But constant evolution, that is the critical thing. You can't be stuck with your old technologies, keep on doing the manual things. You have to have an edge so that you are able to integrate the new technologies.
Perfect. So I think when it comes to developing teams and have this culture of learning, the other factor or factors that can be important is how you are building individual team members. You mentioned learning new tools. I think as a team that's important. You need to be equipped with the latest trends and technology. And I think one interesting thing that we have been talking about since we have been working with each other, which is the team building part and the human development within the teams. So I know you have been running very successful teams, high performing teams. So if you have to put it in a to-do list or give kind of a coaching manual on how to build great teams, what would that be?
The first thing, since you mentioned the human development, my personal opinion, my personal belief, you have to have a personal relationship with you. Some may not agree. It's a corporate culture. You are just a team working together. But if you have a one-to-one human relationship, you know their vulnerabilities, you know their limits, you know what they want to achieve in their life. For example, some members in your team, for some reason, they will want to have an international exposure. One of their to-do list. Someone will want to do a master's. Someone is motivated toward the certification so that they can put on the LinkedIn. So you have to be in account with their motivations, what they want to do. So the best thing, which I try to adopt, which I have learned from my mentors as well, to have a one-to-one with your team members, unbiased, raw discussions, just to understand what they are feeling, what kind of suggestions they are offering. Eventually, at at the very core, everyone wants to excel. Everyone they want to earn more. So you can have discussions with your team. Then you can align their technical goals along with what they want to achieve. For example, if someone in your team is interested in learning in AI, they are a backend developer. So you can assign some tasks. Okay, this is a new technology coming up. So you can have a mix and match of those. So eventually, what you will have a new resource, or a scaled up resource who knows the development. Then he is able to do AI as well. That I have been blessed in that part, having some good team leads. They have been mentoring me. I got some circumstances which I have to take care of few challenges, which allowed me to move out of my comfort zone. At that time, I didn't understand that thing, but now if I look back, I try to transition that into the team I'm working with. So the first thing is this, having a one-to-one kind of a relationship with them. Second thing, if we are talking about team building, I was recently reading from the Islamic point of view. I will give you just brief on that. If you are hiring resources, there must be two qualities in them. One is they should be powerful in terms, the context was around the physical strength, but I understood is they must be powerful in their terms. If you are talking about the good Python developer, they must be very good. They must have some good projects there, and then there should be trustworthy. So if you see some resource when you are taking an interview, so these two things: one, their trust part, and the second is the how much skillful or powerful are there in their skill set. That is a very good hire. And then this thing I have recently adopted, recently learned that people are going to make mistakes. Just be patient. I have done mistakes. I am still doing mistakes. So the leads, the managers I am working with, they are patient enough to just give me room. So just try to give them the culture in which they can grow. They can make mistakes. If they are not sharing their vulnerabilities with you, the stuff which in normal situation they won't be sharing with the team lead, then that relationship needs to be matured, so that you can understand what are the shortcomings of your team. You can invest some time there, and then you will have a healthy culture. And again, these technical tasks, normal stand-ups, that is the conventional thing. I hope everyone is doing this thing. But from my side, suggestion, or from that point of view, human relationship with your team is very essential. And then if you have that relationship, they are going to take care of all the tasks. But they will be trustworthy. They will take care of all the assignments you allocate to them. And then you have the room. Basically, it's all about clearing your schedule, so you don't have to go into the day-to-day fights with the other team, or blame games, meetings. They are taking care of every single thing, and you get your schedule free. You are working on the new ideas, what kind of new innovations, what kind of new technologies, what kind of new product your team can work on. So basically, their task, or they will have a culture in which after some time their technology will get shifted. They will not feel stuck at the same position. They will keep on involving. You yourself, you will be generating more revenue for your company. And again, it's a win-win situation for everyone.
I think it's interesting in a way for the personal development. Two things that you mentioned. One is, can I trust that person? I think that's really important, and trust is something I believe which will happen over time. It's not something you can judge in an interview or working few months with a person. Maybe you are able to detect few people or based on few factors, but I think trust happens over time. It takes time. That's one thing. The other thing that you mentioned is the skills, and again, this is something which I think you do interviews, you do everything to make sure that you are hiring a right person with right skills, but you still fail to do that because I believe in an interview is not a good benchmark for that. So you will assess their skills, and let's say if someone is lacking in skills or you assessed them wrong, so what will you do? Will you give them chances to improve, give them the necessary training, or will you replace them?
Okay. First thing you mentioned regarding the skills of an individual. Obviously, not all the resources you hire will have the complete skill set, except like match of JD you are looking for. You have to take a chance there. That thing, it's a constant evolution for me as well. You make mistakes, you do some wrong hirings. It teaches you. Then you have a one-to-one with the your final interview with the candidate. What I do is I try to understand how they are addressing their last employer. What are the reasons they are giving to me, and how much they are staying in a particular company. Things can go wrong. Maybe they opted for a wrong company. It can happen. If it is happening 1 or 2 times, it makes sense. But if you see a trend that if someone is leaving after 6 months, then there is because if you are hiring someone, it will take some time to adopt to the culture, to understand the product. Maybe 3 months, maybe 6 months, depend upon the complexity. But it will certainly going to take some time. And after that time, you will put on. They will get the pressure. Now you have understood the whole product. Now you have to contribute. Now you have to evolve the product. And if at that time you find a trend in the resume or during the final interviews with them that they are not able to, there is a particular pattern there. So that is a one indicator. And the question you ask, if they don't have the right skill set, definitely that skills can be trained if they have the right attitude. If they own that particular thing you are assigning to them, it can be small task. The one thing which I like an individual, I try to do this myself as well, that I shouldn't have come to you to take a follow-up. For example, if I've assigned something to you and you said that it will take 2 weeks or let's say 1 month, after 1 month, I shouldn't be chasing you that what's happening. And after the last day, you are telling me, oh, this happened, something was not there. That ownership, it's going to take you long. So again, that skills can be taught. Again, technology is always evolving. So it's always a learning pattern there. So skill set is there. The right attitude, these kinds of indicators, how they are treating the old ones, how they are behaving right now. If you are giving them even small tasks, how they are performing on those tasks, what kind of questions they are asking. Are they asking you the obvious questions or obvious questions which are just one Google search away or just one Chat GPT search away? They can simply get almost the basic task, they will simply get it from the Chat GPT. If they are coming back to you with all those small minor things, again, you have to teach them how to be a good Google searcher, how to resolve the problem in your hand. Because there comes a time when you are starting early in your career, you will solve the problem which your leads or your seniors have already solved. But then after a few years, you will be given with entirely new challenges. Maybe it's from the infrastructure point of view, maybe from the security, maybe from the AI point of view. There will be new technologies and no one in your circle will know nothing about. So that thing, the ability to learn new skills, that is going to help them to so they can understand learn new skills. So that is it. If the skill set, it can be taught, provided that they have the right attitude.
Okay, that's good. I think that is for the individual development, right? We are managing someone is working with us. We need to make sure that they are on the right path and they are the ones with the right attitude. But if we talk about, I think when it's about building teams and high performing teams, it's also about the synergy between the team members and their orientation with the overall goal of the team, how important it is for the leader to make those things happen. And is there a way that leader can make those things happen, or are they automatic?
Very good word, leader. Okay, so leader has to lead by example. So again, if you want to, like, if you discuss about setting up the right culture for the synergy of the team, learning new skills, getting these things done, here they will follow the example of the lead. If they will see that the leader is outperforming, he is keeping himself updated with the new technologies, and whatever he's saying, he is being committed to. So they will follow that thing. So you have to make yourself an example. So and then you have to again have meetings with them. Why you are working on this particular product? You have to go on to the human level, because eventually, what leader is, he is there to support his team. He is not that not to command them. He is there to support their team, and that team in a very this supported environment, they will do wonderful things. So what I think is that particular leader, he has to lead by example, and the rest of the team, they will automatically follow whatever he's doing.
That's a good point. Okay, so I think we before we conclude, I want to touch on the topic which is quite hot these days, the artificial intelligence. I am talking to people or in different episodes about this, but what I need to ask you is how AI is changing DevOps, how AI is helping with automation, or will do it in coming years.
Okay, so first thing, if we talk about AI in automation, AI in the DevOps part, Copilot from Microsoft is already enabled in the Azure Dynamics. So if you are seeing some repeated issues, database connectivity issues, configuration issues, Kubernetes upgrade issues, that Copilot is going to help you there. So you are safe from all of the troubleshooting, going to the Stack Overflow, or even searching over the ChatGPT. He is going to give you the right recommendations with respect to the configurations you have performed on your infrastructure. So that thing is already there. So that is going to evolve. REST automation, again that we have already discussed. Automation is with respect to the configurations, with respect to your product. So that with or without AI was already there. Definitely, it can detect few scenarios. You can integrate. I haven't seen it yet, but it can be AI can be trained. It can be integrated with the logs the system is generating, so that it can predict system failure. So that can be a very good application. This is just thinking out loud. So that can be a very good application. And if we talk about the other aspect of the DevOps and the AI, now there are few things which Azure is doing, since they have heavily invested on the OpenAI. AI Studio is there. You can easily integrate your databases with the AI Studio. You have already models running there. So imagine you are creating, you are training your own large language model. So and that model knows the system with respect to your custom data. So you don't have to train it again and again. So the low level implementation of the AI RAG is going to be there, and you just pass on some queries. The system is going to, that bot or that AI custom Copilot you come up with, it is going to go inside your database. It is filter out all the queries, and it is just going to give you some of the results you are looking for. So that thing is already there. And again, regarding the day-to-day operations, ChatGPT and other tools are most of the team are already using it. So normal debugging, it has significantly reduced the time.
You smile at ChatGPT.
Actually, it helps you. Okay, but to
overuse can be.
You have to be smart enough to use it.
Yeah.
So if you are expecting, you have to be again as I said, smart enough to use it.
Even the prompting is
Prompt engineering is very good.
Right?
Like you have to understand. You have to understand how prompt engineering is working, how you define the problem to the chat GPT, and how you like send the data. Like if you are working with the YAML files or they are low level DevOps configuration, that thing like you can try to give a good context, and eventually it will solve, like it will reduce the time to debug all the issues. So that thing is going to be there. But yes, it is it's not like that always going to give you the right answer. You have to be smart enough to know like what things to be implemented. That core basics, which we have already discussed, or which DevOps engineer, infrastructure engineer, even the developer, they know it. So they have to the whatever ChatGPT or the Copilot is saying, and along with the basic exposure, the experience they have developing multiple applications, utilize that. Then you can you reduce the time. If you're just relying on ChatGPT, the reason I smile, you will end up with more problems rather than, again, it is just going to give you multiple iterations of one thing again and again. And if you keep on trying that and coming up that this solution is not solvable, like this problem is not solvable, then you are wasting your time.
Yeah.
Then you have to use your actual skill set plus whatever AI is giving you, use it, and then definitely you can reduce the time.
Yeah, I think with respect to AI, I have another question, which is everybody is asking, but I'll ask specific to DevOps and infrastructure. Do you see a time in future where infrastructure, DevOps, and the whole dev operations will be managed without human involvement?
Okay, so to rephrase your question, what you are asking is that will there come a time in which human intervention in the infrastructure or the cloud environment will be completely eliminated? But I think no, because if you talk about the complex systems, there will be some scenarios in which you need to understand the underlying architecture, what kind of services you have to use, what are the limitations of these services.
AI is understanding that. Won't it be able to solve them?
It has to be, like if you're talking about those critical systems in which you have to process millions of records, you have to then do analytics on top of that, and then you have to do a very cost efficient infrastructure. So these kind of scenarios without human interventions, it will be difficult. But definitely if you have some AI engine giving you trend and analysis, cost anomalies, that these are it's been the costing advisor or the normal cloud advisor, it has been there for quite some time. It gives you a recommendation that this virtual machine is not being utilized, it is being underutilized, please shut this off. Or if this virtual machine is not being reserved, please go for a reservation, it is going to save you this % of cost. So these kind of recommendations always been there. But if you talk about the complete infrastructure, the whole system level architecture, these are core skill sets which if you go toward the basics, even now, even the communication with the IoT devices, do I have to opt for TCP, do I have to opt for UDP, do I have to use MQTT broker, or do I have to go for the WebSocket? So these kind of scenarios, these are learned after working with multiple IoT devices and over the exposure. So and that thing, it can't be replaced by the AI. So definitely you need a human intervention there to optimally use.
So it will less the burden of human or decrease the human involvement, but won't take the whole control of it.
I don't for now I don't foresee completing it completely going away. But yes, if you talk about the general structure of pipelines, general configurations, it can give you recommendations that if I for example, if you're going to create a virtual machine, it can give you recommendations that for these kind of workloads, these are the recommendations, and with just one click you can lay that infrastructure. But optimizing that infrastructure, fine tuning that, then you need someone with an experience, the exposure, who has the exposure to optimally manage the infrastructure and eventually have a very optimal cloud billing eventually, because you don't want to overspend on cloud infrastructure. So that one or two resources with a expertise on that, it will be there.